So we're going to carry on with our discussion of routing protocols. We've just discussed convergence, and let's jump into the two major types of routing protocols. The first of which is distance vector. An example of distance vector routing protocols are RIP and IGRP. IGRP is the predecessor to EIGRP, which we'll talk about here in just a little bit. Distance vector routing protocols give you two basic bits of information. Number one, what interface the route or the remote network is known on, and number two, how many hops or what the distance is to that remote network. Now, as you can tell, distance vector routing protocols generally don't take into account the speed of the links between the two networks. If you have a network that is one hop away that's across a 512K partial T1, and you have a route that is 3 hops away that's over DS3s, well, it's always going to choose that 512K link, even though it's slower, because it has fewer hops to get to the destination network. Obviously, in most functioning networks, that is not the most efficient way to handle this. And that's one of the main reasons that distance vector routing protocols aren't used on large networks. There's also some limitations built into the most commonly used one, which is RIP. And we'll talk about that a little later when we talk about RIP in depth. Distance vector protocols generally broadcast their route table on a fixed interval. In the case of RIP, it's about every 30 seconds unless you change the defaults. And so as we discussed when we talked about convergence, this can lead to a very high convergence time, because the more routers you have in your network, the more 30-second intervals it will take before the addition or deletion of a route makes it from one end of the network to the other. The other type of dynamic routing protocol is called a link state routing protocol. Examples of link state routing protocols are OSPF and ISIS. OSPF is used pretty heavily in the non-Cisco world. ISIS is generally used by large providers like Verizon and AT&T, Layer 3, the big people like that, if they're not using BGP or some other routing protocol. But we won't get into that because this is ICND1 and we're talking about CCNP topics. Now, a link state routing protocol, or a router that's running a link state routing protocol, keeps a local topology database. And because it has a local topology database, it knows the layout of the entire network. Unlike distance vector routing protocols, which knows that network is 3 hops that direction, the link state routing protocols will be able to tell you all of the routers that it goes through and the relative speed of the links that it goes through between point A and point B. Unlike distance vector routing protocols, link state routing protocols broadcast changes to the network topology as they happen. So if you have a router that's running OSPF and one of its links goes down, it will recognize, hey, this link is down after just a few seconds. It will recalculate its local copy of the topology database and will send that updated change out to all of its connected neighbors. Because of this, link state routing protocols have a much quicker convergence than distance vector routing protocols. They're more complex to configure and administer, but the payoff is that the convergence, again, is much higher than you'd get with RIP or IGRP. Now, I know that I said that there are two major types of routing protocols, and there are, but there are a couple that are considered hybrids. They have characteristics of both types of routing protocols. Some examples of that are EIGRP and BGP. And again, we won't get into exactly how they're hybrids, but just know that hybrid routing protocols have characteristics of both protocol types. In the example of BGP, for example, by default, it uses hop count just like RIP, but you can use a set of path attributes to modify the behavior of BGP. And again, if you go for the CCNP course, you'll learn, I won't say all about BGP, but you'll learn a lot more about BGP in the CCNP course. So now let's talk about the metric that routing protocols use. And quite simply, the metric is a function of the routing protocol that tells you how reliable a given route is. When I say how reliable a given route is, I really mean how good one route is versus another. To go back to our example of the RIP network with the varying speed links, if you were running OSPF or BGP, then OSPF would realize, yes, path A has fewer hops, but path B has a faster link. And so, as a result, path B will get a better metric than path A, because even though it's more hops to get there, it'll get there quicker because there's less congestion on the link. Generally, in most routing protocols, a lower metric is a better metric. It's kind of like a golf score, I guess. And one thing to keep in mind is that metrics are specific to a routing protocol. A RIP metric is not necessarily the same as an OSPF metric. Again, RIP's metric is very simple. It's simply hop count. How far away is that network? where OSPF takes into account link speed and delay. In EIGRP, there's this whole complex mathematical formula that it uses, and it uses various K values to determine what the best route is and what its metric is. And this is internal to the routing protocol. So if OSPF learns about the same network from 4 different sources, it will look at the metrics and say, well, this one has the lowest metric. This is the one that's actually going into the routing table for the router to actually use. Which brings us to the last concept we're going to talk about when we talk about routing protocols, and that is administrative distance. And administrative distance is to routing protocols what the metric is to an individual routing protocol. Essentially, it tells the router how reliable a given routing protocol is. For example, let's say you're running OSPF and RIP on one of your routers, and you learn the route to the same network via OSPF and via RIP. And the router says, well, I have these 2 routing protocols. They're telling me that the network is accessible via different directions, but they end up in the same network. Which one of these do I believe? By default, it'll believe OSPF over RIP. And there's a whole table that you can look at to determine which routing protocol is believed over which other routing protocols. And that's freely accessible on Cisco's website. I'm pretty sure you don't have to know it for the exam. You just have to know what the administrative distance is. The administrative distance tells you which routing protocol has the best route to a given network. Just like metrics, the lower the administrative distance, the better or more reliable the protocol is, and the more likely that that particular route from that routing protocol will be installed in the routing table. And that concludes our discussion of routing protocols.